Okay, we're 1/4 finished, so we got 3 more lessons that we need to go over for the Unit 4 exam. And so now this is a review of lesson number 7 on things that are rotating. So this is going to be chapter 8 out of your textbook, sections 1, 2, and 3, and then section 7, and then section 8. Okay, I would like for you to know what a radian is, and I would like for you to be able to convert from rotations to revolutions to degrees to radians. Okay, so all of these are different descriptions of angles, so that when you've got a tire, and this is not a tire, but if you have an object and you're rotating it, it's rotating through an angle. And so 1 unit for an angle is the rotation. So if you go completely around in a circle, that's 1 rotation. If you only go halfway, then that would be a half a rotation. So a rotation is a unit for an angle. The revolution is a unit for an angle. The degree is a unit for the angle, but the official metric unit for an angle is the radian. And so let's make sure that you know how to do this. So convert 45 degrees into a radian. So how many radians is equal to 45 degrees? So you're always going to do 2 sets of parentheses. And in the first set of parentheses, you're going to write down the what you start with. So in this case, we're starting with 45 degrees. In the second parenthesis, we're going to write down our conversion factor. So we're trying to get rid of the word degree, so I need to put the word degree on the bottom. And I'm trying to get to the word radian, so I'm going to put the radian on the top. And now I need to go back to my conversion factor. So it says that 360 degrees is equal to 2 pi radians. And so with your calculator, you will need to put in, for this, you need to put in 3.14. So you're going to take 2 times 3.14 and then divide it by 360 equals, on your calculator, and then times 45. And then it turns out to be 0.79. And then, see, this canceled out. So the only unit left was the radian. And then you could also convert radians into revolutions. So this is a good skill to learn, how to convert 1 unit into another unit. Okay, why is this important? Because all of the formulas for things that are rotating involve radians. So when you're describing how a wheel is rotating, the angle through which it rotates always has to be in terms of radians in order for that formula to work. Okay, so let's take a look at these formulas here. Ignore the stuff that's in green because it's not going to be on the Unit 4 exam. It is going to be on the final, but let's just concentrate on what's in the orange area there. So for something that is rotating, the distance through which it rotates is going to be the angle. And so that is going to be given by theta. So theta is going to be the angle through which a tire rotates. Okay, then the speed at which a tire rotates is going to be given by omega. Kind of looks like a W, but notice I make it different than this W up here. So this is going to be the Greek letter omega, and it is going to be the distance that something rotates per unit time. So I would like for you to know that formula. So the distance that something rotates, the angle through which it rotates per unit time, is going to be called the rotational speed. And now what I would like for you to be able to do is something with RPMs. So an RPM means rotations per minute. And so this is the unit for omega that I would like for you to be able to use on the test. But in actuality, what you really should be doing is radians instead of rotations, and then seconds instead of minutes. But let's not worry about that. So can you do a question like this? So a wheel is rotating at 500 RPM. How many rotations will it make in 30 seconds? So that's the level that you need to know in order to be able to use this formula here. Okay, I also would like for you to know acceleration. And so acceleration is given by alpha. So this is the Greek letter A. And you see what it does is when you accelerate, it changes your speed. Just like when something is moving sideways, when you accelerate, it changes your velocity v. So this is changing the rotational speed when you accelerate. So I'm not going to have you do anything with this formula, but you should know what does rotational acceleration mean. So what is it, if you're looking at something that is rotationally accelerating, what does it look like it's doing? So that's what I would want you to be able to do. All right, ignore this, okay? Not going to be on the exam. But I did want you to see that for each formula, for things that are moving sideways, there's an equivalent formula for things that are rotating. But that's not going to be on the exam. So just let that ooze out of your head. Doesn't that feel good? Okay, good. Let's take a break. When we come back, we'll talk about the connectors between things that are rotating and then things that are moving sideways.